I've been looking over the quiz scores. It's great to see so many of you've got that quiz one out of your way. Most of you did extremely well on it. I know some of you still don't have internet, don't have Wi-Fi. On those individual cases, please send me an email. Let us talk about when you can get those things started. We're going to continue today with section 1.6 that will finish up chapter 1. And what that means, we did 1.4 and 1.5 Tuesday, 1.6 and 2.1 today. 1.4, 1.5, and 1.6 are the sections that had to be covered before you can do quiz number 2. Quiz number 2 is due next Monday. I suggest as soon as you get this homework finished, quiz for 1.6, you go back, look at your sections 1, 4, 5, and 6 briefly, and then go ahead and start that quiz. Don't wait until Monday to get that thing done. Now, this homework on 1.6 and 2.1, according to the schedule, it is due on Sunday night, but you don't have to wait until Sunday to do it. You can do it anytime. Today, we have two really short sessions. And the first in 1.6 is dealing with absolute value. Absolute value of 5 is equal to 5. The absolute value of minus 5 is also 5. By definition, the absolute value is how far a number is from 0 on the number line. So if I put a 0 here and I put me a 5 here and I put me a minus 5 here, both of those are the same distance from 0 on that number line. And that's our definition of absolute value. Now, when you're doing this homework, don't fall for the traps. In fact, he has quite a few of them that are traps. Here's a perfect example. The absolute value of x is greater than 0. Now, and he says, is that true or false? Well, it's false because of one simple fact. If you put in 0, the absolute value of 0 is equal to 0. So this is not a true statement. Now, if I put in the absolute value of x is greater than or equal to 0, then the answer would always be true. But this answer is false. And I think you have one just like that in your homework. Also, be careful of another trick. The absolute value of x is greater, say, minus 3. Well, the absolute value of a number is always 0 or positive. That's what we just said in that statement in the previous problem. So that means that this thing right here would always be true. The absolute value is always going to be greater than the 3. But if we turn this mess around, if I tell you the absolute value is less than negative, let's say 5, well, the absolute value is always 0 or positive, so this thing would have to be a false statement. Now for the meat of what the lesson is about today. The absolute value of x is less than, let's say 8. Well, let's try a few numbers that will work. If I put in 1, certainly that works. 2 works. And I can go all the way up to 7.99. And that would still be a true statement. The absolute value of 7.99 is 7.99, which is less than 8. But look at the other end of the scale. If I put in minus 1, minus 2, minus 7.99, that still works. The absolute value of all those numbers come out to be positive, and it stays less than 8. The thing is, we got a theorem right here. The absolute value of x is less than 8, means that x is between 8 and minus 8. Now memorize that. Look at that fact. When the absolute value is less than a number, it means it's between the negative and the positive of that number. Let's look at it on the number line. If I put it on the number line, I put a 0 here, and I put an 8 here, and I put a -8 here. Well, all of these numbers work. Now, in this case, for my interval notation and what we learned in the last section, we're going to use parentheses there. So all the numbers between -8 and +8 would work this initial statement up here. So when it is less than, it's very easy to make us an equation out of it. In fact, we can make it in this simple inequality right here, and it works every time without exception. Now, once more, don't fall for his traps. If he gave you this problem, the absolute value of x is less than -8. You can't work that. That's a false statement because we just got through saying the absolute value is not less than a negative number. Okay, watch what happens when you go the other way. The absolute value of x is greater than 8. Well, let's look at it on the number line. This is 8, and this is -8. If I pick any number bigger than 8, that's going to work. If I put in 9, the absolute value of 9, that's going to be greater than 8. If I put in 10, 11, 12, any number to the right of 8 then is going to be greater than, let me get this camera focused, 8. None of these numbers in here make it greater than. We just saw that they all make it less than. Good morning, Ms. Johnson. I'm glad we have somebody with me here. Can you speak up? Let's come back the other way. If I put in -9, -9 would be back to the left. But if I put in -9, the absolute value of -9 is 9, and that is greater than this 8. So when it is greater than, and I want you to look at it very carefully, you have to make two situations. X is greater than 8, and x is less than -8. There's no exception. When it is greater than, you have to make your two problems out of it. X is greater than 8, and x is less than -8. Let's go back to a couple that's equal to, and let's see what we're going to do with them. The absolute value of x plus 3 is equal to 5. Okay, there are two ways to work this problem. First, this one right here, you can just see. I think if you see, if you let x be 2, 2 plus 3 is 5, and the absolute value is 5 is 5. But then there's also another value of x that would work this thing. My recommendation is this. You simply make your two problems out of it. What's inside the absolute value can be +5, and what's inside the absolute value can be -5. Now get used to this, because we said to start with, when we use 5 originally, the absolute value of 5 is 5, the absolute value of -5 is 5. So anything in here that makes this 5 will work. Anything in here that makes this -5 will work. Well, the first one says that x is 2, and the other one says that x is -8. So we get two answers in. X is 2, and x is equal to -8. And I beg y'all, check these, review an example, and make sure that you write the answers in the manner that they want the answer written. They probably just give you a box, and you're going to write down 2, -8 in that box. Many of you, when you did your quiz, you worked the problem right, but you answered the problem as x is equal to, let's say 2, and they only wanted you to put a 2 in there. And it doesn't make a whole lot of difference on homework, but it makes a big difference on quiz because they're going to mark that thing wrong. So keep in mind, when you absolute value, you have to make 2 problems out of it. It's either to the positive of that quantity or it's equal to the negative of that quantity. Now, we can take that same route to do it with the inequalities. If I had got the absolute value of x plus 4 is less than 6. Well, we said just a while ago, when it's less than, what's inside has to be less than 6 and has to be greater than minus 6. Now, one more time. What's inside has to be between 6 and minus 6. We worked this back in an earlier section. We're going to keep the x in the middle, so we're going to subtract the 4 all the way across. So I got minus 10 is less than x is less than 2. So the answer to this thing then is everything between minus 10 and 2. Now, he probably wants you to write that in interval notation, so you're going to write it from minus 10 to 2. Now, I want you to notice that we keep it in parentheses, and we keep it in parentheses because it's not less than or equal to. It is simply less than. The only thing we can do to make these things look a little bit worse is just soup them up, but they're really all the same thing. Okay, our first step then is going to be to keep the absolute value on the left side by itself. So I'm going to subtract that 5. I got the absolute value of 2 minus 4x is equal to, subtract 5 over here, and we get 18. Now, so this says that 2 minus 4x is equal to 18, and 2 minus 4x is negative 18. I have the habit of doing it this way. You can do it whichever way you wish to. I always keep my number in front of my x positive. So I ran the minus 4x over to the right side. I run the 18 back to this side. So I got minus 16 is equal to 4x. So x is minus 4. Over here, I got 2 plus 18 is equal to 4x. So I got 20 is equal to 4x. So x is equal to 5. So I get 2 answers. I get an answer of minus 4, and I get an answer of 5. As I said, the only thing that makes this look worse is all this a bit of adding and subtracting, but it doesn't make any difference. You're going to end up with the absolute value on one side by itself, and then you make your 2 equations out of it. Okay, let's say the absolute value of 3 minus 2x is less than or equal to 7. Again, we can make it simple. It's between 7 and minus 7. So we're going to subtract 2 all the way across. And I get minus 9 is less than or equal to 3x is less than or equal to 5. Now, we divide by the 3. And I get minus 3 is less than or equal to x is less than or equal to 5/3. So this time we record the answer with brackets. And we record the answer with brackets because this thing is less than or equal to. What about Johnson? Are you here with me? If so, speak up.
Yes, sir, I'm here.
All right, good enough. Pronounce your first name for me.
Carson?
Carson. Good, Carson. Good to see you again. And you've been here a couple of times. Do
Yes,
you
sir.
actually watch these videos?
Yes, sir.
Do they help?
Yes, sir, they do.
All right, that's what I need to know because we've got a lot of, I think probably not major changes, but changes down the line as to when I can do this. Were you going to be able to do it if I did it in an evening time? I sent out a survey on that.
Yes, sir.
You would be able to come at that time?
Yes, sir.
I think I might change it to that, but I'll let y'all know. I'll send out an email talking about that. Does this
Okay.
does this make sense what we're doing right here?
Yes, sir, it does.
All right. Did you take this in Algebra 2 or Advanced Math in high school?
Yes, sir, I did.
All right. That goes a long way and helps a whole lot, doesn't it?
Yes, sir.
Okay. Now, let's do a so-called, well, let's do one more greater than. The greater than is the one that gives people more trouble. So let's do another one of those. So let's say I got the absolute value of 5x minus 3 is greater than or equal to 7. When it's greater than or equal to, you have to make two problems out of it, and that's crucial. So 5x minus 3 has to be greater than or equal to 7, or 5x minus 3 has to be less than or equal to negative 7. Got to overemphasize that negative because that's what makes it work. The arithmetic is very simple. So 5x is greater than or equal to 10. So x is greater than or equal to 2. And then I got 5x is greater than or equal to minus 4. Not greater than. Keep me straight here, Carson. When I make a little boo-boo, holler at me, okay? X is less than or equal to minus 5/4. Now, you have to record this thing separately. You can't condense this into one answer. So the first part of the answer is I start at 2 and I go to positive infinity. The second part of the answer is I have negative infinity to negative 4/5. Now, we use the bracket there because of the fact that it is greater than or equal to, or it is less than or equal to. One more out of this section. Now, this thing is supposed to, they're saying it's difficult, but it's not difficult. Well, we've covered all the stuff. But let's give it a try. The absolute value of x squared plus 2x minus 4 is equal to 4. Well, we've already said, make two problems out of it. So what's inside the absolute value has to be equal to plus 4, and what's inside the absolute value has to be equal to minus 4. So you're going to make your two problems out of it. So let's deal with this one first. So this says that x squared plus 2x minus 8 is equal to 0. Well, we're lucky. This thing will factor. Let's review the second section that we covered. The factors of 8 are 8 and 1 and 4 and 2. 8 and 1 won't give me this 2 in the middle, so I'm going to have to use the 4 and the 2. Now, this is the big deal with factoring. This middle sign goes with the biggest product. So that says that this 4 has to be positive. The fact that this is negative says that the signs have to be opposite. So this one would have to be negative 2. So I got x plus 4 is equal to 0. And I got x minus 2 is equal to 0. So x is going to be negative 4. And x is going to be positive 2. So I have two answers here. I have 4, negative 4, and positive 2. Now watch this next one. This says that I got x squared plus 2x, and when I add 4 to both sides, this gives me 0. Surprisingly enough, many people have trouble with this type of equation. When we started factoring, I hollered common factor. Well, that's what you got to use here. We're going to take out the common factor of x, and I got x times x plus 2. So I get two answers. I get x is 0, and I get x is minus 2. Now, we got 4 answers simply because not because it's squared here, but because it was absolute value and squared. But the important thing is that we've got 4 different answers. I got -4, I got 2, I got 0, and I got -2. And I beg y'all, when you do these things, view the example and see which way he writes that answer, because the way he writes that answer is terribly important. How'd you do on your quiz, Carson?
Pretty good.
That's good. I think I looked at nearly all of them, and if there was anything I could change, I did that. In fact, many people, let's say the answer was both been 5. They wrote X is equal to 5. The computer only wanted the 5 in there. Well, I can give y'all credit for one like that. I'll take a look at your quiz again and see.
Thank you so
Okay.
much.
Now, we've just finished section 1.6. I'm going to say it again. 1.4, 1.5, 1.6. That's the sections that you need to have done before you take the next quiz. The next quiz is due Monday night. You don't have to wait until Monday night to do that thing. As soon as you finish those 3 sections, 1, 4, 5, and 6, I would say, while it's fresh on my mind, I'd go ahead and do my quiz and get it out of the way. That would give you a chance to, if you need to make a couple extra tries at it, you could do that. Okay, that's chapter 1. Let's go to section 2.1. 2.1 is a different ball game. 2.1 is talking, first of all, about just knowing how to plot points. Many moons ago, there was a fellow by the name of Rene Descartes, or Descartes, whichever way you want to pronounce it. He decided that we can chop the plane up into 4 regions. We call this quadrant 1, we call this quadrant 2, and we call this quadrant 3, and we call this quadrant 4. Now, why he labeled them counterclockwise instead of clockwise, I don't think I've ever found that out. It doesn't make any difference. But this point right here, where the X and Y axis cross, has a name. And that name is called the origin, and that is the point 0, 0. So if I'm going to plot the point, oh, let's say we're going to plot the point 3, 2. Which quadrant am I going to be in, Carson?
1.
Right, because you go 1, 2, 3, up 2. So this is my point 3, 2. Fair enough? Now, let's say that we're going to plot the point -4 and 3. So which quadrant am I going to end up in?
2.
Right. 1, 2, 3, 4, and then we're going up 3. So this would be the point -4 and 3. And then if we want to plot the point -2, -3, then I'd be in the 3rd quadrant. -2, -3 is down here in the 3rd quadrant. And if we wanted to plot the point, oh, let's say 4, -1. 4, -1, we would plot right here. Now, I kind of assume that all of us already know how to do that, but that's something that we need to make sure that we can handle because of what we're trying to do with this. The first thing we need to talk about, in fact, that we're going to talk about, is what we call the distance formula. In other words, how far it is between 2 points on a plane. Well, let's don't get it on the plane. Let's just get it on the number line first. If this is my 0 point, and let's say this is 3, and let's say that this is 9, then how far is it, Carson, from 3 to 9?
6 points.
It's 6 points. So the distance between these 2 points is 6. Agreed?
Yes, sir.
Well, what the rule is this. If I tell you that I got 2 points, A and B, the distance between those 2 points is the absolute value of A minus B. Now, notice he don't care which way you put these things, which one you put down first, because we're going to take the absolute value of it. In my problem right here, I'd have 3 minus 9. 3 minus 9 is minus 6. But how much is the absolute value of minus 6?
6.
6. So you see, it works. This little formula right here, I want you to keep in mind. If I have a line and I want to find the distance between it, just subtract them and take the absolute value of it. If they happen to both be positive, then you wouldn't have to worry about absolute value because it would automatically be positive. Okay, but the thing is, they're not going to all stay in this form. So what happens then, if I have a point up here, let's say that I have the point up here, and let's let it be 9, 6. And then let's say that I have a point down here, and it's negative 3, negative 2. Okay, and I want to know how far it is from those 2 points. Well, you can't just subtract the values and get that, but watch what we can do. So if I come down here and I locate this point, 9 minus 2. Now I want you to watch what I did. I drew me a vertical line there, so all the x values are going to be 9. And then I draw me a horizontal line here, so all the y values are going to be minus 2. So look at what I have then. I have a right triangle. And I'll be willing to bet, Carson, that you know what that is called. A squared plus b squared is equal to c squared. You remember that?
The Pythagorean theorem?
Right, that is a rule of Pythagoras. In fact, that is of utmost importance, and that's going to get us out of a whole bunch of problems right here. So I want you to watch what happens. In this problem right here, how far is it from minus 2 up to plus 6? Isn't it going to be 8? Agreed?
Yes, sir.
Yeah, because minus 2 minus 6 is minus 8. The absolute value of minus 8 is 8. Or if you want to go the other way, it's still going to be 8. Agreed? All right, let's try the other one. How far is it from negative 3 to positive 9? Isn't it going to be 12?
Yes, sir.
Right. So in this Pythagorean theorem, we always let C be the slanted side. C was the hypotenuse, right? So what that says then is that C squared is going to be 8 squared plus 12 squared. Well, we're off and running because this is just pure arithmetic now. 8 squared is 64. 12 squared is 144. So C squared is 208. So C would be the square root of 208. Now, we never talk about a negative distance when we're talking about, like if you measure the size of a room, you don't talk about negative 20 feet or something like that. So that C is always going to be a positive value. Now, I'll agree that there's probably a bunch of things that we could do with that 208 as far as breaking it down. I guess, let me not get too lazy and go ahead and follow through with something that I said the other day. 208 is 4 times 52, I think. Yeah, 4 and 2 is 8, 4 and 5 is 20. But 52, it also has another 4 in it, so that means that I could have divided it by 16 to start with. I'm talking to myself now, okay? Now, 4 times 13 gives me 52. 3/4 is 12, 5. So we're in pretty good shape. So this comes out to be the square root of 16 times 13. So the answer is 4 times the square root of 13. Now, I don't know how far course compass is going to go to making you do it like that. But if you did come out with this answer, the square root of 208, then he would expect you to break it down and write the final answer as 4 times the square root of 13. Now, the good part about it, though, is that we can develop a distance formula, and we don't have to do all this right triangle stuff. All we got to do is plug into the distance formula. Now, I'm going to use what I've already got so that we won't have to rewrite it. If I call this point up here x2, y2, and I call this point down here x1, y1, then this distance over here is y2 minus y1. And this distance at the bottom down here is going to be x2 minus x1. Well, then that means that my c up here, c squared, would be equal to x2 minus x1 squared plus y2 minus y1 squared. So if I want to get c, I just take the square root of that. And that's our distance formula. I'll put it on the other page so that we can clean up the mess, but using it is what's going to be the important thing. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And honestly, y'all need to go ahead and memorize that formula. It's not that difficult. You subtract the x's and you square it, you subtract the y's and you square it. So let's give it a try on our last problem. On the other page over there, the 2 points were 9, 6, and -3, -2. Now, let's just plug that into that formula. So the distance is going to be the square root of, and it's going to be -3 minus 9 squared plus -2 minus 6 squared. So this is -12 squared plus -8 squared. So it's square root of 144 plus 64, which is square root of 208. So the distance formula works, and it works very simply, and it works every time. Fair enough? Okay, the other formula that we need is what we call the midpoint formula. Carson, how do you get the average between two values?
Add them together and then divide them by how many you have.
Amen. That's the way you get total average, right? If I had 5 of them, I'd add all 5 of them up and divide by 5, right?
Yes, sir.
But when I'm just dealing with two things, I just add them together and take half of it, right?
Yes, sir.
So what it says then is that the midpoint formula simply says you add the x values and you take half of it. You add the y values and you take half of it. Fair enough? Well, let's use these same points that I just had up here. I want to find the midpoint of that. So it'd be 9 plus a -3 over 2, and it'd be 6 plus a -2 over 2. So this would give me 9 minus 3 is 6 divided by 2, and this is going to give me 4 divided by 2. So the midpoint of this thing would be 3 and 2. Agree? And it's that simple. Don't make it complicated, okay? The midpoint, you simply add them and you take half of it. Okay, you got a problem that goes like this in your homework. It gives you 3 points. Be about halfway draw its scale, but I don't care about the scale. It gives you the point -6 and 3. Well, that's over here in the second quadrant. And then it gives me the point 3, -5. 3, -5 is over here in the second quadrant. And he gives me the point -1 and 5. -1 and 5. And his question is this a right triangle? Well, Carson, what are the two things you remember about a right triangle?
It has a 90-degree angle.
Right?
And
And the other thing is what we just said. The rule of Pythagoras works. Agreed?
yes, sir.
Yeah, the rule of Pythagoras works. So if I call this point A, this point B, and this point C, well, I got my work cut out for me, but we can do it. Let's see how long AB is. Well, AB is going to be the square root of, and it says I subtract the x's, so it's -6 minus a -1 squared plus 3 minus 5 squared. Now I subtract the x's and I subtract the y's. Now we got to be real careful with our arithmetic. So this is -6 plus 1 squared, and this is -2 squared. So -6 plus 1 is 5. 5 squared is 25, and 2 squared is 4. So that side comes out to be the square root of 29. So far, so good? Okay, now let's find BC. BC is the square root of -1 minus 3 squared plus 5 minus a -5 squared. And so this is -4 squared, which is 16. And this is 10 squared, which is 100. So it comes out to be the square root of 116. Now, let's find AC. AC is the square root of -6 minus 3 squared plus 3 minus a -5 squared. So this is 9 squared, which is 81. And this is 8 squared, which is 64. So that comes out to be the square root of 145. Okay. Now, so these are my three sides. Carson, which one looks like the hypotenuse?
AC.
AC, I would suspect, is the hypotenuse. In fact, look at the numbers that we got right here. Isn't the square root of 145 bigger than the square root of the other two?
Wait, I couldn't hear you. Can you say that again?
I said, the square root of 145 is larger than the square root of 116, and it's larger than the square root of 29, right?
Yes, sir.
So AC has to be my greatest side. So we're going to check it out, and we're going to see the greatest side, which is a square root of 145 squared, and we're going to put us a question mark. Is that equal to the square root of 116 squared plus the square root of 29 squared? Well, the square root of 145 squared is 145. The square root of 116 squared is 116. Square root of 29 squared is 29. Add 116 and 29, what do you get? I wrote this down wrong. That's supposed to be 145 there. Isn't that what 116 plus 29 is?
Yes, sir.
Right. So that means that we're off and running. That thing is a right triangle. It's a right triangle because the rule of Pythagoras works. Is that right? Okay, we only got one more thing to do with this mess then. And the other thing that we need to do is talk about the area of a triangle. from our geometry. The area of a triangle is 1/2 the base times the height. The area of a triangle is 1/2 the base times the height. Now, when I got a right triangle, we're in good shape because one leg is the base and the other leg is the height. Does that make any sense?
Yes, sir.
Because the height was the perpendicular distance to the base. So when I got a right triangle, finding this area is very simple. So we look back at the triangle that we just had. In my leg, one of them was the square root of 129, the other was the square root of 116. So the area of that triangle that we just did is 1/2 the square root of 29 times the square root of 116. Now I got no earthly idea how big that is, and I don't care. But to get the area, you simply plug into that formula. One's the base and one's the height. Fair enough?
Yes, sir.
Okay. Another question that they has. He's going to ask you a question like this. Is 6, 8, 10 a right triangle? How are you going to answer that? How do you know if 6, 8, 10 is a right triangle? Again, you're going to use your rule of Pythagoras. The longest side is 10, is that right?
Yes, sir.
So 10 squared, and we'll put us a big question mark. Is that equal to 6 squared plus 8 squared? Well, 10 squared is 100. 6 squared is 36. 8 squared is 64. Whoop, 36 plus 64 comes out to be 100. So it is a right triangle. Now, I'm going to charge you just a little bit. I know you had to do pretty well on the ACT or you wouldn't have been in college and in this class. Do you remember 3, 4, 5 right triangle?
I don't know.
Okay, 3, 4, 5 is one that we use really, really often. I want you to look at these numbers right here, 6, 8, 10. If you just double 3, 4, 5, wouldn't each one of them be 6, 8, 10? Which means that we really didn't have to work it out. But the big deal is very simple. You can find the area of a triangle when you know the base and the height. And he's going to ask you if it is a right triangle, and we just work one out the hard way to find out if it is. So we've done section 1.6 and section 2.1. So I'm going to say it again, folks, if you're watching this video. Complete your section 1.4, 1.5, 1.6, and then you're ready to take quiz 2. Quiz 2 is due Monday night, but you can do it anytime before that time. And then I'm probably going to send out a blanket email, and we're going to give it one try of changing these times for these lectures, because I don't have many of them showing up in the morning. And I think the main reason is that many of them have morning classes and they can't show up for it. Good luck with it, and get your quiz done as quick as you can. Have a good day, Carson.
Thank you. You too.